So what we're talking about here is the physiology of an action potential. And what we said was that we had a ligand-gated ion channel that caused a local potential to travel over here, and now we are at the trigger zone, right? We're at the trigger zone. And this is what we're seeing in terms of some local potentials that are coming this way. But this one got strong enough to depolarize us to threshold. And once that ligand-gated local potential reached threshold, we now have a voltage-gated ion channel that opens for sodium, and sodium rushes into the cell, causing the cell to become less negative, 0, and then positive, all the way up to about 35, positive. And we call that depolarization. And remember, it's due to the influx of sodium cation. Now what happens is when we get just about to the top, we shut the sodium gates and we open the potassium gates. Now these things are flowing down their concentration gradients. Sodium flows in because sodium is higher outside. Potassium is higher inside. So if we open a potassium gate, that potassium flows out. When you take positive charges away from something, you're making something negative again. So we call that repolarization. We are making the cell membrane negative again. And we actually overshoot a little bit. We get a little too negative, and we call that, we have hyperpolarized, hyperpolarization. And then we're back to our resting threshold, which is anywhere from -70 to -90. Threshold's about -55. And we have studied that we can have summation of these local potentials, so they can be additive effect, they can be inhibitory, where they're pulling away, further away, and then the bottom line is the average of what gets to the trigger zone is what's going to count. Now we also talked about this concept to keep this thing going in one direction, antegrade propagation, one directional movement. And the way we do that is we use these refractory periods where that neuron cannot be stimulated to generate another action potential. And up to the point where this action potential finishes or comes back to resting threshold, that's absolute refractory period. These gates are locked tight and you can't open them. You cannot stimulate. But notice that during this hyperpolarization period, you can stimulate it, but you've got further to go. See how it's going to take a stronger stimulus, a stronger local potential to reach threshold. So we call that refractory period relative refractory period. These are all or none. Once you fire them, they're going. They're always the same strength. You can't stop them. They're all or none. Local potentials, however, can be excitatory, they can be inhibitory, they're graded, they can be different strengths, they fatigue, they're short-lived, they go less distance, they're reversible, and of course they're ligand-gated, whereas an action potential is voltage-gated.
Thank you.